Hey Shanequa, so the questions that you sent me, I'm going to go ahead and just walk you through it because that would be a little bit easier. The first one that you sent me, I think it says that it's number 6. That one is a two-part question, as it's kind of following up with what we learned with the dosage formula. If you remember the D over H times Q, that's the first question that's being asked. It's asking us for the amount of dosage, the amount of drug. And then the second part is asking us for the flow rate. And flow rate is milliliters per hour. So they probably should have specified that in the question, what they meant by flow rate. But when you see flow rate, that's typically what that means. So that's going to be utilizing the IV formulas that we talked about. So the first question, when we're asked for the amount of drug, there's only certain parts of this question that we need. The question says that what's been ordered is the gentamicin 50 milligrams in 250 milliliters D5W. So that just shows how much medication has been diluted into 5% dextrose water, which is just in an IV, to be given over 60 minutes. So here's what we'll need. From that, we only need the ordered dose when we're trying to calculate, how much drug is going to be given. Oops, I did not mean to write milliliters, milligrams. Sorry. Pay attention, Ellie. Okay, milligrams. There we go. 50 milligrams. Right now, don't worry about how it's diluted. We're just trying to figure out how much medication is going to be given. On hand, we have gentamicin 100 milligrams. So there's our dose on hand per, 20 milliliters. So there's our DH and Q. Remember what happens when we calculate this. The two units that are the same are going to cancel out, which is going to tell me how many milliliters are going to be added. When it says piggyback IV, piggyback just means, not that you guys have to know this right now, it just means kind of an IV on top of an IV. It's typically, if an IV is given as kind of there's a constant IV where sometimes a patient is getting fluids over a long period of time. Sometimes there's an added medicine to the IV given intermittently. And that's called a piggyback IV, that it's just a different IV that's given, intermittently between that continuous IV. So this medication, as we calculate that, 50 divided by 100 times 20, this would be 50 divided by 100 is 0.5 times 20 would end up giving us 10 milliliters. So that's the first part of that question, is how much drug is going to be given. Now, the flow rate is going to be what comes from, that order that said, that it's 50 milligrams, but it's diluted in 250 milliliters. Remember, milliliters per hour, that's all we need. We need the total amount of milliliters that's going to be given, which is 250 milliliters. Excuse me. And then needs to be given over 60 minutes, which we know 60 minutes is the same thing as 1 hour. So it's 250 milliliters per every 1 hour. That's milliliters and hours. When we divide the two, 250 divided by 1 is 250 milliliters per hour. Since the units are not the same, nothing cancels out and leaves us with milliliters per hour. And that's why that answer is as such. In your email, the title said that you didn't know how it's 10 or 260. You may have typed that incorrectly and meant 250. If for any reason the Connect says 260, it is incorrect. So I apologize for that. Connect sometimes has its own share of issues, but it should be 250 on that, and that's how we got that. So I hope that makes sense, that in that two-part question. Now, the second question that you sent me, sorry, I'm trying to read this while I'm writing here. First one we went over, this one here, that it requires the dosage calculation and the flow rate calculation. And then the one that you sent me is also a flow rate question. So it says, so that's so tricky, because sometimes when it says flow rate, it means milliliters per hour like it did in that previous question. This one says flow rate, however, it says flow rate, but it wants to know GTT/minute, which is drops per minute. Remember, the formula for that, for drops per minute, says that we just take our volume in milliliters, our total volume, divided by the time, which is, again, typically given in hours, but we need it to be in minutes since we're trying to calculate drops per minute. and then we multiply by a drop factor. So that's the formula we're going to follow here. So for this, I think it says number 16. For number 16, what you sent me, we are going to take that 1,000 milliliters, and we're going to divide it by the time. It says ordered is 1,000 milliliters of D5W over 8 hours. Now I see. Okay, so it's having us adjust this. I'm just now reading it while I'm writing this. I'm sorry. Calibrated to 15 drops per milliliter. After 2 hours, 150 milliliters has been infused. Calculate the adjusted flow rate. Okay. Let's see. On this one, so I guess what's going to have to happen on this, it's just deducting what has already been given. So you really don't, so it's almost like we're going to take it as though it's just what's left. So that's how I would calculate this. For what's been given, the total was 1,000 milliliters, but it said 2 hours have gone by and we've already given 150 milliliters. So if we take 1,000 and take away 150, that means that there are 850 milliliters left. So that's the total volume that we're going to use. The original time was 8 hours, but again, 2 hours has passed, so that means 6 hours are what is left. And again, we need this to be in minutes. So remember, what we're going to do is we're going to take 6 hours but multiply it by 60 to get that into minutes. And so in green is where I'm having this, writing down this final calculation down here. 6 hours times 60 is 360 minutes. And then the drop factor is just the same. It's just using that type of tubing. The drop factor there is 15. So the adjusted flow rate would be to take 850 divided by 360 and then multiplying that by 15. I got 35.41666, which would round to 35 drops per minute. And I am looking at number 16 on the homework right now, and it does say that that is the correct answer for that. It should be 35 drops per minute. All right, so I hope that helps with those two questions. If you have any other questions on anything, please don't hesitate to ask. I'd be glad to help you with any others, but that hopefully helps with those particular calculations. I know that those are some trickier ones and some strange ones, but don't worry, I don't have any of those that either like the first one or the two-part question, like don't have anything on the final that requires something like this where you have to calculate the adjusted flow rate. It's very, very similar. The final just is very similar to what we did in the lecture, where it's just very straightforward. Well, I'll give you these numbers and I want you to calculate the drops per minute, and that's it. So just kind of a heads up. Sometimes I know that Connect is designed to just really kind of make you think, and it looks like it did that for us today. All right, if you have any questions, let me know.